Thank you very much. I have the unenviable task of delivering a testing talk in the morning. So yes, we're going to be talking about UI testing with Lustre and also Gleam. Now, if you haven't heard of Gleam yet, A, what are you doing in this room? B, if you spend enough time in this room today, there's going to be a whole bunch of Gleam talks and you will walk away knowing probably a lot more than even me. So maybe a little bit about who I am. I'm a front-end web developer by trade, actually, so I'm kind of an imposter in this room. I've got maybe 7 or 8 years experience doing Elm. And yes, I am the author of Lustre, which is a front-end framework for Gleam. So I'm giving a testing talk, but I have a confession to make. And I hate writing tests. I hate writing UI tests. And the reason for that is maybe going to sound a bit familiar. So let's say you've joined a team, or you're working on a new product, or it's a startup. You're in ship mode, build, build, build. You're writing code, you're feeling good. You ship to production, the champagne is popping. And then you get a message on Slack or an alert from Sentry, and everything's on fire. Your users can't sign up, you can't print money. And so you all get together and you're like, okay, how do we make sure this doesn't happen again? And you're low on resources maybe, or you're really focused on still shipping new features. So you decide that you're going to write some end-to-end tests for your core user journeys. Now, these are when you spin up maybe a web browser as part of your CI pipeline. You use a browser automation library like Cypress, and you say, okay, visit this page, interact with the page as if I was a user, type some inputs, click a button. And then you might take a snapshot. This is typically a screenshot of the page that you then save, you commit. And the next time that test runs, if there's a difference, you can use your eyeballs to see that change. And so these snapshots report when things change, and they hopefully act as a smoke signal for bugs or issues that you can then dive into the code and investigate. And this works well for you in the beginning. You're shipping new features, you're being diligent, so you're writing more and more of these kinds of tests. And then over time, your CI starts to grind to a halt as you're spinning up an actual browser every time. Maybe you're not even caching the browser download. And now your lean, fast-moving startup is grinding to a halt, waiting for CI to run. And then after all of that, it turns out you didn't even really test anything in the first place, and you get hit with more bugs. So we're going to talk about whether we can do better. And I'm going to put forward that good tests know what is being tested. And when we do these kind of browser automation tests, this is really kind of just throwing things at the wall and hoping for the best. And I think that UI tests come in 4 main categories. So the first is business logic, like the code that computes something, does something. Then we have presentation logic, our code that decides what to render and when. We have our content. We want to test whether, the words that we're using is right. Do we have the right tooltips? Is the prose correct? And then also we want to be able to test for design. Does it look how we expect? Is it following our design system? Is it using our design tokens? So first, let's take a little second to look at what we're up against. I know this maybe isn't a front-end heavy room, but the allure of React is always there, right? Even if you're a back-end developer, probably if you're looking at technologies, React is going to come up. So this is a kind of imaginary login component, right? And most React components kind of follow this sort of structure, where first we set up our component state. So I have, like an email and a password field. I have some state to track whether we're currently loading, and also I'm going to store an error in case something comes back from our backend. And then a bit further down, we'll look at behavior. So here I have like a handle click function. It sets some state. It fires off some HTTP request, to fetch our user session, login. And then, of course, the important bit, I guess, we have our render logic. So we're going to return some markup here. We might access some of that state to change what we're rendering. And the question is, how do we test this? Because all of those pieces, they're bundled up into a component. We can't really get at each of these individually. And so we're kind of forced to test this like a user would. And we're now kind of back in this world of browser automation or like interacting with our code as a user. So now we're going to have to interact with the page again. We're going to have to fill out inputs when really we want to be testing the code we've written. So how can things be different with Lustre and with Gleam? Well, this is kind of the scaffold again for one of these login components or a login page. And just like before, we have some state. Here we're using typed functional programming now. So I'm going to define the state of my program or my login form as my model. I'm going to store that email and password again. Instead of storing a bunch of booleans, now I can have like a submission status and use like a nice enum or a custom type, as we would call it, to model that state. We'll move on to behavior. Now we have messages, and we can say, I want to handle the case when the user types something for their email, and I want to handle the case for, they click submit. And we write an update function that takes a message that has come in and the current state of our program, and we return, a new state for our program. And kind of interestingly, we also separate apart our side effects. So here, RSVP is a library for Lustre for doing HTTP requests. And this is a second separate thing that we return from our update function, independent from our state updates. And that's going to come into play in a little bit. And then, of course, finally, we have how we do rendering. Now, in Lustre, there's no templating language, there's no extra markup language. Here we're purely in the world of functional programming. And that means we're constructing HTML through function calls. And when we want to emit events, handle input changes or clicks, we're not going to write that code directly in our markup. Instead, we're going to dispatch one of those messages. So in this case, when the user types something into this input field, we're going to send a user changed email message with the new value that they've typed in. And because this isn't a special markup language, we also have easy access to all of the language features that Gleam has. So this is a small example of pattern matching. I assume everyone in this room is already familiar with that. So how is this different? Well, these parts are explicitly separate. In the React example, we kind of separated out our component into these sections, but the component itself was the main unit. But here we have distinct separate functions for updating versus rendering. And then the runtime pulls these together into like an update loop. And normally when I give this talk, this is when I say, like other front-end frameworks, Elm, Redux, there's state management patterns for Vue. They all follow this pattern. But probably for the people in this room, this looks pretty similar to one of these, like a process or an actor where we have an update loop and some message passing. And this separation, that's our superpower when it comes to testing. So I had these 4 categories of tests, the kind of things that we might test for in a UI test. And I'm going to go through each of these now and look at how that separation really makes it possible to pinpoint each of these categories. So the first is business logic. Obviously here we're going to want to be doing unit testing, and we'll be unit testing our actual business logic functions. But even more interesting perhaps is that we could just unit test our update function. And that means we can start asking questions like, what happens if a user clicks submit with an empty form? And we can assert, I expect that the state of my program will look like this. And so here you can see we initialize our model with some empty fields, okay? So the user hasn't typed anything yet. And then we call that update function with a message. They click submit. And then we can make an assertion about what we expect the state of our program to be. And this doesn't involve running it in the browser. Now, to run these tests in Gleam, you would use a community test runner. The one that most people use is called Gleam Unit. Moving on to our presentation logic. Like I said, our views are just functions and data. So we don't have any fancy templating. We don't have any macros. We don't have anything like that. And this is a power because it means that we can use all of the techniques we already know about testing on our view code. So as an example, here I'm going to view our submit form. And I'm going to make sure it's in a loading status. And I can quite simply just make an assertion that I expect, okay, there's a typo in this slide that should say HTML instead of output. I can say, I expect the HTML returned from this view submit function. I expect it to be a button with a loading spinner. Now this is a little bit annoying because now I have to go in and reattach these event handlers, right? Because we're doing straight assertions of the data, if I left this out, I would have two different pieces of view code and this assertion would fail. But because our views are just data structures, that means they can be queried. And Lustre comes with a module for doing queries on elements, HTML. And so we could write this like this. Again, we have some model with some initial state in it. And we'll view that model. This will run our app's entire view function. And then we can go in and we can say, OK, I only really care that there is some sort of loading spinner on the page when the model is in a loading state. Now, actually, we can go a bit further. We're doing functional programming, so why don't we think about how we can compose some functions? Now I'm initializing that model, and then I'm running my update function with a message, and then I'm rendering it, and then I'm querying it. But why stop at just one message? Why don't we simulate multiple messages to kind of mock up a user journey, but not in terms of the browser, but in terms of this kind of domain-specific language we've already come up with our messages? And so we could have a sequence of messages. The user has typed something in as their email, then they press submit, and then our API returns an error. And that could be just something as simple as folding over that list of messages. But actually, this is such a powerful idea that there's an entire simulation module in Lustre that lets us simulate an application and then say, hey, simulate that you got this message, simulate that you got this message. And at any point in that simulation, you can hook in and you can say, oh, I want to know what the model is right now so I can make an assertion about that. Or I want to know what the view is so I could make an assertion about that. And actually, we can go further and we can start simulating actual browser events using that kind of query DSL. So we could simulate a click event here on some button with an ID called submit. And in this case, we're not going to send any JSON payload. But now we're making sure that if there is a click event on this element, we're going to get a message in our update loop. And now we can start saying, does this work correctly? And moving on, we can talk about content. And this is where I'm going to bring back the idea of snapshots, things that can change. But instead of taking browser screenshots, what if we took text-based snapshots using a library called Birdie? So here I'm using that query API again. I'm pulling out some part of the markup using a selector. And I can take a snapshot of that. And now I can be like, OK, this is very easy to read. I'm checking for content. This is easy to understand. And when it changes, I'm going to get a really nice diff that tells me, OK, we changed the label from email must not be empty to email is required. And maybe that change was intentional, maybe it wasn't. And last, the fourth thing that we want to be able to test for is design. So we're probably going to need a browser for this. And the common tool that people use here is Storybook. But slowly but surely, I'm also working on something for Lustre here called Fable. And this is where you load up your UI code in a kind of isolated environment where you just have like components that are rendered on the page. And that separation, again, is our superpower because we can just use our view functions. We're not coupled to logic. We're not coupled to side effects. We can just say, render this view function on the page and show me the component with this particular state. Now, good tests know what is being tested, but a good strategy knows what to test. So if you're building internal tools, then maybe you only want to test business logic. But if you're on a sprint with a product focus, or like you're really, really focused on like user experience, then you might start testing presentation logic and the content. Or if you're building a design system, then maybe you want to test presentation logic and design. And because we have those isolated, separated components, it's very easy to target our test strategy based on what we're building and what our goals are. So to recap, Lustre kind of empowers our testing strategy, both in its architecture and the kind of modules and ecosystem of packages that are available. So we have testing libraries, Glee unit for running tests, Birdie for making snapshots, and then we have these testing modules, queries to simulate an app or run like a Storybook kind of clone. And then finally, maybe end-to-end tests are still useful for our core user journeys, but we don't need to start leaning on them for everything. Thank you for listening.
Thank you very much. We have 2 minutes for questions. Are there any questions from the audience? Okay, we have one.
Thank you very much for your talk. What's the magic behind simulate?
Pardon?
Behind the simulate method, what's the magic behind it?
The magic, actually, there is no magic at all. That's the great thing, right? Because these are just really normal Gleam functions. Actually, all the simulate module does is it just handles the magic of calling your update function and then your view function. And so it really doesn't do anything special. It just provides like a very convenient API for working with this.
Thank you. Anyone else? Okay, one more.
Hello, really good. I should try it. Do you have any tips for making sure that the messages you have in your user journey are reflective of what would happen in your real application?
Yeah, so actually that's the kind of value of this simulate API. Once you get to this point, now we're not talking in terms of messages, we're talking in terms of user interactions. And so what you're then testing is actually, like I expect this particular message, but we don't have to say that explicitly because we're working from the context of our user interaction.
Awesome. Thank you very much.
Thank you. If there is one more short one, we still have time. Okay.
Hi, great talk. Can you recommend how to get started with Lustre for someone who's never used it?
Hell yeah, I can. If you go to Lustre Labs/Lustre on GitHub or the hex docs/Lustre, there's like a quick start guide. There's like 20 plus examples. There's like a deployment guide. There's really, really good docs. So.
Okay, thank you. That would be all. Thank you for attending. I hope you will stay with us. Don't forget.